Okay, another application of this markup and discount would be in cases of faulty machines, essentially. Any kind of reading machine which is creating an error. Let's say, and what kind of error? So let's say a machine where when you put 1000 grams, it shows 900. The meter shows only 900 grams, okay? Or where, let's say you put 800 grams and it shows 1000 grams. I mean, a case where it is reducing the actual weight and where it is increasing the actual weight, at least what's visible, okay? So what impact would this have on the scenario, okay? So what is happening, this is the actual weight and this is the shown weight, or we'll look at more of this, okay? So if nothing else, if there is no other markup and discount story provided, what will happen? Even if the trader sells it at cost price, what would happen, okay? So let's say the cost is 1 rupee per gram, or the gram itself is the cost, okay? It could be in any form, right? But let's say for easier thinking, 1 rupee per gram. So the cost here, or the CP here, would be 800. But when the customer comes in and this 800 gram is put on the machine ends up showing 1000 grams, right? So, or it could also be a case that on one of the sides of the pan an extra 200 gram is attached. So the moment you put 800, it becomes 1 kg on one side and it shows 1 kg on the other side also. But in any case, the customer will see 1000 grams and you're saying, the trader is telling everybody that I'm selling it at cost price only. So even at cost price, which was 1 rupee per gram, the customer will pay 1000 rupee. So the mark price in this case, and also the selling price, right? Because this is the shown price and the selling price also is 1000 rupees. Same numbers only. So there is I can say a markup before the deal has happened, or a profit percentage, because they are the same only, of 200, markup and profit of 200, or a markup and profit percentage of 200 by 800, which is 1 by 4 or 25%. So essentially this machine, when it increases the weight, when it shows the weight more than it is providing a markup only, and the markup percentage can be figured out very, very quickly. In this case, the markup percentage was 200 by 800, this being our base because this is our cost as such, okay? And similarly, if the machine was showing 1000, when you put 1000 grams, it shows, when you put actual weight, shown weight, it shows 900, there is a discount of 10% being offered, right? Straight away, we can think like that. Because the cost is 1000, but the customer will pay only 900, 100 rupee over a base of 1000 is getting deducted, okay? So, but once we understand it, that any error in the machine is either creating a markup or a discount, our life in such questions could be very, very easy and fast, okay? So, let's look at this example again. Let's say there is a machine, when you put 800 grams, it shows 1000 grams, okay? And the trader says, I will give a discount to 10% to everybody, okay? So what will be the overall profit percentage in the deal, or loss percentage, okay? I can do this by a very long discussion, but very, very quickly, I know this is creating a markup of 25%, yes? 200 by 800, 200 by 800, 1 by 4 is giving me 25%. So CP into 5 by 4, right, from previous examples is happening. There's a markup of 5 by 4 happening. And there is a discount of 10%. So this becomes a 9 by 10. This is giving me the selling price. This gets cancelled. So I get CP into 9 by 8 is equal to SP, which means a profit of 12.5%. 9 by 8 means an increase of 1 by 8. 1 by 8 is 12.5%. So therefore a profit of 12.5%. So I didn't have to worry too much about this. I just needed to understand that this is a markup being created, and then the rest of the story just fits in usual. Okay, stop. Okay, so another case, discount is given as 20%, but because of error in the machine, even after the discount of 20%, there is still a profit of 20%. So error in the machine, or fault in the machine, or a faulty weighing scale, whatever the scenario, because of that machine error, even after a 20% discount, there is a profit of 20%. And the question is, if the machine is showing, let's say, 150 grams, how many grams were put on the machine? It is showing That means what is visible is 150 grams. So what is the actual weight put on the machine? Okay, we'll come to this part later. First of all, here, if I look at after the discount, we still have a profit. That means there is a markup. The only difference between this question and similar question that we've done earlier is, in this case, the markup is being provided by the faulty machine. But we know there is a markup. Let's denote it by A by B. I do not know what it is, but it's A by B for now. 20% discount means a multiplying factor of 4 by 5. Okay, and this will take me to the selling price. There is a profit of 20%, which means selling price is 6 by 5 times the cost price. Now this cost price gets cancelled, this 5 gets cancelled. A by B, or the multiplying factor for the markup, is 3 by 2. Right? That means the actual weight is multiplied by 3 by 2 and you get to the shown weight. Right? That's what we figured out earlier. So now I have the shown weight, which is 150 grams, right? That means the actual weight must have been 100 grams. So essentially, if you want to look at the question backwards, when on the machine, when you put 100 grams, it shows 150 grams. There is a increase of 50%. There is actual increase of 50, but 50 on a base of 100 means an increase of 50%, right? So there is a markup of 50% being provided. So if you had only this information, you would have converted this into 3 by 2 or new by old, which you've seen again earlier over and over again. So CP into 3 by 2, there's a discount of 20%, so into 4 by 5. So if you work this out, you get CP into 6 by 5 is equal to SP, and 6 by 5 would mean a profit of 20%. So all the information matches together. Okay, so this was just changing the form of the equation. Stop. Another variation of the same error in the machine would be impurity mixing. So let's say a milkman has 5 liters of milk. In that, he decides to add 1 liter of water. He is mixing in impurity water and he is basically cheating in the process. Okay. But what is happening because of this? The total is becoming 6, right? Isn't it the same as the machine providing a markup of 1 on 5 or you providing a markup of 1 on 5? So, or if you want to take an example wise, let's say the milk was 10 rupee per liter, so the cost was 50 rupees. If the customer will see 6 liters and even at 10 rupees cost, he will give you 60 rupees. So what was 50, you are getting paid for a 60, that means there is a markup of 10, or percentage wise there is a markup of 20%. Okay. So, or this information could have also been presented as he has added 20% impurity to it, right? That means impurity is 20% of the original and you get to the total, okay? Or the language form would be he mixes impurities in such a way that impurities are 20% of the original, right? So when there is a 20% impurity, it straight away creates a 20% markup. So this information again is converted into a markup only. Another way of giving this information could be he mixes impurity in such a way that it is 20% of the total. Impurity is 20% of the total. So now, which means 1/5 of the total, right? So if the total is 5, impurity is 1. The total is 5, impurity is 1. So pure stuff would be 4, right? So 4 plus 1 is giving you 5. The markup here is going from 4 to 5, or if there's an increase of 25%, the markup would be 5 by 4. Is that okay? So this 20% you would think typically 1 by 5, and you might think the multiplying factor would be 6 by 5 or 4 by 5, but nothing like that. This 20% of the total will convert into it being 20% of the total, therefore being 25% of the original pure material, and therefore creating a markup of 25%. So I hope that idea was clear. We'll practice this more in coming examples. Stop. Okay. Let's say our trader mixes impurity in such a way that impurity is 10% of the total. Okay. And he gives a discount of 10% also. He gives a discount of 10%. So what is his overall profit or loss percentage? Okay. So we have this discount of 10% very clearly, we'll use it later. This impurity is 10% of the total, means 1/10 of total. Okay, that means if the total is 10, impurity would be 1. That means pure stuff would be 9. So 9 plus 1, you're getting to 10. So the markup, what is 9 is being shown as 10. So there is a markup of 10 by 9. So if I want to go back to my earlier CP, there is a markup of 10 by 9. There is a discount of 10%, which means a multiplying factor of 9 by 10. CP into 10 by 9, which gives you the mark price, into the discount gives you the selling price. This 9 gets cancelled, this 10 gets cancelled, SP is equal to CP, so there is no profit, no loss in this particular case. Stop. Okay, again, two forms of the language we want to look at. Let's say he adds impurity, 20% extra impurity, right? 20% extra, that means 20% of the original is the impurity. That means out of 5, if there is pure 5 stuff, we are adding an impurity of 1. 20% means 1 by 5, and we are getting a total of 6. Contrast it with the earlier form where we said impurity is 20% of the total. Here we are saying 20% extra impurity is being added. So whatever we have, 20% extra of that is the impurity. So the multiplying factor here is 20%, right? Or 6 by 5. But if in this story there is no other discount, there is no other markup, then the profit would also be 20%. So that could be a shortcut in your head, that only if impurity is being added and it's being given in this extra form, so whatever is the extra percentage impurity being added, that would be the profit percentage straight away. So if somebody said 25% extra impurity was being added, straight away that would imply a profit of 25% if there was no other discount or markup in the story. Okay, and remember, two forms, 20% extra is very, very different from saying 20% impurity is 20% of the total. Very different language forms. So pay attention to that. Stop. Another problem where we mix these two forms, impurity as well as faulty weights. Okay, so let's say our trader mixes 20% extra impurity, which means impurity is 20% of the original pure material, which will get added to the impurities. Okay, 20% extra impurity. He gives a discount of 10% and still makes a profit of, let's say, 35%. Okay, yeah. And there is also a faulty weighing scale involved. So when you put 400 grams on that weighing scale, how much will it show? Okay, so first of all, what you should have noticed is that he has mixed 20% extra impurity. If there was no discount, this 20% extra impurity straight away should have caused a 20% profit, but there is a 35% profit even after a 10% discount. That means there is another markup. This is going to provide me with a markup, but there is another markup also, which is being provided by the faulty weighing machine. So let's start with the multiplying factors involved here. So I know that I start with CP, 20% extra, that means on 5, 1 is being added to get a total of 6. So the multiplying, there is a markup of 1 on 5, or the multiplying factor for markup because of this story would be 6 by 5. Because of the faulty machine also, there is another markup. There could be 2 successive markups, there is no problem with that, but I do not know what it is. Okay, this is my final mark price. On that there is a discount of 10%, which means 9 by 10, which gives me the selling price. But the selling price, there is 35% profit. That means selling price is 35% more than the cost price. 5% is 1 by 20, 35% would be 7 by 20. 7 into 5 gives you 35. An increase of 35% means 27 by 20 CP. Yeah, you can pause, rewind, think in your own head how this came about. Now the CP gets cancelled. Now let's start working this out. This gets cancelled here, this gets cancelled here, right? And after, what else? This gets cancelled here, and A by B eventually reduces to 5 by 4. That means the markup provided by the faulty weighing scale is 5 by 4. That means whatever you put, it is increasing by 25%. Or in this case, A would be the shown weight and B would be the actual weight. You know the actual weight is 400 grams. Shift the actual weight here, put 400 here. This gets cancelled, you get the shown weight as 500 grams. So when you put 400 grams on the machine, it shows 500 grams. So if you think again, this is giving you a markup, this is giving you a markup, then you're giving a discount, and then you're giving a resultant profit, and here is your chain of multiplying factors put all together. So this might be complicated, but this is a very good example of a lot of things put together. But all of those things have been discussed, small pieces have been discussed earlier. So I hope this made sense. Yeah, sure. Another form of this error is what we know as a meter scale. It's out of fashion these days, but earlier you would go to a clothes store and you would measure your cloth by the meters, and you would have a metal scale for doing it. Basically it's 1 meter or 100 centimeters long. So you put it next to the cloth and you know there's 1 meter of cloth, so it's a metal scale. But what happens to metal is, in winters it shrinks and in the summers it expands, okay? So let's think of the summer scenario first. And so the scale is 100, let's say centimeters, right? And it shows 100 centimeters only. But in the summers, it expands. So this is the actual length normally, right? But in actual length in summers, it becomes 110 centimeters. But what is shown, if you look at the scale, it still shows 100 centimeters only and 100 marks only, and the customer will not think that it's summer and it has expanded. So it shows 100 only, right? So this, what is happening essentially is, this is actually 110 centimeters, right? So when you're measuring your cloth, you're measuring 110, but the customer will see only 100. So actually a discount is being provided of 10 upon 110. Is that okay? Similarly, if in winters the scale shrinks, we'll come back to this number, don't worry. If the scale shrinks, the actual length normally is 100 meters, the actual length in winters would become, let's say, reduces by 10% and becomes 90 centimeters. Now the scale has in reality become shorter. When you put it next to a cloth line and you measure it, you will get only 90 centimeter, but it will still show 100 only, because the markings are still there and it's not a digital machine which is fluctuating, it just says 100 centimeters. So in this case, there is a markup of 10 by 90 or 1 by 9 being provided, okay. So we have to understand that in summer, when the scales expand, a discount is being offered, and how much is being offered, we can, if we put the numbers together, we can get it very, very quickly. And in the winters, when the scale shrinks, there is a markup being provided, and how much is the markup, we can work that out, okay. Stop. Just more data to work with. Let's say in the summers the scale expands by 20%. So basically the scale which is 100 now has become 120, but remember it is 120 but it will show 100 only, right? So there is a discount being offered of how much? Of 20. On a base of how much? 20 by 120, or basically 100 by 120 is your multiplying factor. So 20 by 120 is 1 by 6, so your multiplying factor for discount is going to be 5 by 6. So remember, this 20% expansion becomes a 16.66% discount. So don't use it directly as 6 by 5, or if you want to use it directly, flip it, 6 by 5 becomes 5 by 6. We have already done inverse variation with the same thing happening here, okay. Similarly, if in the winter it shrinks by 20% and it becomes 80, right? It is 80 but it will still show 100. That means there is a markup happening. 80 is being shown as 100. The multiplying, the change is 20 by 80 or 1 by 4 or 100 by 80, which is 5 by 4. So there is a markup being provided of 5 by 4. or 25% markup is being provided. So again, even in winters, this 20% will not straight away convert into 20%. It'll have to be converted into some other number, in this case, which is 25%. So, but putting the number and putting them in an order which you can see and understand will be a great idea. So I hope this idea made sense. And with these scenarios, it pretty much covers all kind of errors in the machine. And remember, it's not about the errors in the machine, it's about markups and discounts being applied, which themselves are nothing but percentage increases or decreases. So you understand how percentages work, all of this other information is quite secondary. Yeah, okay.